Hi, my name is Dr. Gregory Wiedman. I'm a professor in the Department of Chemistry and Biochemistry at Seton Hall University. When I thought about what I wanted to do as a scientist, I realized that what I could do most to help people was to try to address something that some of the most vulnerable people in our society deal with. Those of us who have HIV/AIDS, who are immunocompromised, or those of us who are elderly in long-term care facilities. One issue that all of these groups deal with is infectious diseases, and in particular, drug-resistant infectious diseases. That's what my lab, the 3B lab, Biochemistry, Biophysics, and Biomaterials lab, tries to do. We use various different methods together to try to address the complex problem of infectious diseases, and specifically drug-resistant infectious diseases. The general thinking about treating diseases in the past, and particularly infectious diseases, is that you could develop one perfect molecule or one perfect treatment to deal with all of these problems. What we've come to realize is that that's not really the best way to go about doing this. It's difficult to get one treatment that works in all cases, and just by the nature of infectious diseases, they can develop resistance to these types of treatments. So what we aim to do is to combine our knowledge of biochemistry, biophysics, and biomaterials in order to make treatments that work together with existing molecules, existing treatments, and also have new ways to kind of control it. So for instance, we've developed peptides that can be used in combination with existing drugs to make them more effective, to try to tackle drug resistance in certain types of fungi. We've looked at making treatments that are photodynamic, that can be used with light to kind of activate them in new, exciting ways. And we're thinking of also trying to use pH or redox potentials to make these molecules active as well. We've also had some experience developing biosensors to kind of track the concentrations of these drugs in our bodies. That will help us to understand how much of a certain molecule or combination of molecules do we have to add to make it effective. What we aim to do here is to bring as many people into our projects, our way of approaching this as possible. So we're happy to have any kind of collaborators work with us, students, people who are undergraduates, people who are graduate students. We've also been able to have some success. We've published papers. We've been able to get both private, industrial, and public funding from the government, and we hope to continue that success.